Okay, so last week we looked at distance protection. We discussed in the main what the purpose of the protection schemes that we looked at. We looked at the purpose for using those schemes. And some of what I said last week will be repeated today. We mentioned, for example, the direct transfer schemes, etc. The permissive underreach, permissive overreach, and of course we mentioned the blocking schemes. And we also spoke about the acceleration and extension, zone and extension scheme. That was a very, very senior moment. But anyway, so in all of these schemes, we mentioned the whole business of signaling. So I want to talk a little this afternoon about just that, signaling, and what is required and what are some of the things that need to be considered when we look at signaling for your protection system, right? So going back to what we repeated ad nauseum last time, is that in order to have this fast clearance of our faults and whilst speeding up the clearance time and also allowing appropriate relays to operate, which is what we mean by discrimination. We need to have signaling between the two relaying points. We also, when we looked at differential protection and we spoke about the voltage balance scheme being used for feeders, you'll understand that there would be the relay would be located in a substation, but of course you need to get the information from one point to the next. That is also a form of signaling. In those systems, we are looking at pilot wires, which are, well, we'll define it in a few minutes. But the point is, and I think we said it last time, that the setup that we presented for those distance schemes, that they are replicated at both substations between which the line is connected. Okay? All right. So the links that are available to us, or the protection medium, or media rather, that are available to us include one, we talk about private pilot wires or channels, and this would be installed by the company itself. So it would be like JPSCO going in and installing these pilot wires, which are physical wires, twisted copper pair between relaying points. Of course, you can see where there will be some limitation in terms of distance, okay? Or pilot channels. So the distinction here, for your pilot wires, as I said, these are continuous copper, twisted copper between the two stations. For the pilot channels, these are what we refer to as discontinuous pilot wires with isolation transformers or repeaters. The term repeaters is what you would find more widely used in the industry. Now, what does this really entail? For your repeaters, they allow you to go longer distances. And it is easier for me to describe this from a telecom standpoint rather than a power standpoint, all right? So in your communications system, what you have from the central point, which is where you would have your frame and all these wires, each telephone number. And this is now going back to the old days where you had, everything wired. It's not where we now have the, fiber and that sort of thing. But where we had everything wired, I keep forgetting how young you people are. Yeah, I keep forgetting. Anyway, let me try and hopefully you can identify with it. But there was a point in time when calling Kingston from, say, Manchester would be what we refer to as a toll call. So you'd have local calls. We are now at what, 10 digits? Back in the day, you could dial 5 digits around Kingston, okay? Because all the numbers in Kingston started with 92, all right? So all you needed to do was to dial the other 5, okay? It's 925, 927, 92, all right? So when you're in specific locations, all the numbers are hardwired. Now, once you start going outside of the locale, you then have toll services. Why toll? Because, let me see now. All of you familiar with Manchester? That's the only place outside of Kingston that I know, all right? I mean, I don't think I need to go into why it is the best parish, but apart from that. But if you're calling from Mandeville to, say, Williamsfield, you would pay toll charges, because in Mandeville, the area code would be 962, but in Williamsfield, it was 963, or 963. Why? In order to make the connection between Mandeville and Williamsfield, what would be done is that there would be what we call a trunk line, which would now take mass information from the central office, and it goes down to somewhere close to Williamsfield. But to ensure that whatever information comes on that physical line is relayed to Williamsfield, we would then have what is known as a repeater. And all the repeater does is to pick up the information up to that point on the physical cable, and then reproduces it and passes it on. The same will be true with what we're talking about here in terms of pilot channels. It picks up information from the pilot wires up to a point. It then reproduces the original and passes it on. So it means that you can now go over longer distances, all right? Now, if you were to transmit or pass that information over the single copper wire, because you're dealing with ones and zeros, and the one is a threshold 5 volts, okay? By the time it gets to where it's at, it may have fallen below that 5 volt or fallen even to below 3 volts and would no longer be recognized as a 1. Am I making myself clear? So what you do is to bring it up to a point where it does not fall below 3. And so you can reproduce it as a 1. If you then see something coming to you, which was, say, below, I don't remember what the threshold was at the bottom end, but let us say it was now at 1 volt, that will be reproduced as 0. So you get back your 1, 0, your ones and zeros, which you can then move on. Are we clear? So the repeater stations, they are looking for threshold values. So you have a high threshold, you have a low threshold. Why was the low threshold important? And I'm saying all of this because it's going to impact, or it will impact, what we do with our tripping schemes. The low threshold is there because if you're transmitting over copper, you're dealing with interference from external sources. So it means that you can have a signal being superimposed on that copper, although you avoid that by using twisted pairs, but you can have noise, which we refer to as unwanted signal, being superimposed on the copper pair. So when it gets to the repeater, unless the value that it sees is above the threshold, then it will put it back to 1. Because what you want to pass on are clear 1s and 0s. Am I clear? All right. So that's what we do with the pilot channels in terms of producing the original signal that would have been available. And these are normally, although we said that it can be done by the power company, but normally it will be rented by the power company from the communications provider. All right. The other options that one would have would be your carrier channels. And these are carrier channels which are superimposed on your power lines. Right? So these would be your power line carriers. Good. And well, as the name suggests, the signal is superimposed on the power line. But of course, I hope you would appreciate the challenge that this creates. Because remember, the signaling, let us say, well, we're doing a distance scheme. What are we protecting? In using the distance scheme, what are we protecting?
Sort of like feeders. Protecting feeders.
We're protecting lines. Yeah. No, for the power line carrier, if I'm protecting a power line, it means the possibility exists for me trying to communicate on the affected line. You with me? It's because I'm superimposing the signal on the line. Now, the question is, what fault would we have had on the line? You have absolutely no idea, right? So if I'm superimposing, let's say, on a line that is experiencing an open circuit, it means that the signal would not have reached the other end. Are you with me? Because the very line that I'm using it to protect is what I'm using to carry the signal. So those are some of the challenges with our power line carriers. All right, you also have radio channels. And by radio channels, what we're talking about are microwave, right? Microwave signals. So you'd now have the signal transmitted via microwave. The biggest challenge with microwave is that you need line of sight. So if you're protecting a line between two substations, you have to ensure that the antenna from one substation is looking directly at the other antenna at the receiving substation. All right. So obviously you're going to be limited in terms of the use of radio channels or microwave. You're going to be limited by terrain. Because if you have, hills or mountainous areas between the two substations, okay, you can't really, I have to say this properly, you can't fully dictate where you place a substation. Whilst there will be ID locations, you have to locate it based on the load center and the availability of property in the area. Good? So you may end up with a situation where you either have to use reflectors to go around certain facilities or certain structures or certain landforms, use reflectors to go around mountains. Yes, we used to do that in the communication space. And the same is true. So with the microwave, the limiting factor here is a terrain, whether you're dealing with mountains, etc., because you require line of sight for your microwave. And then the other possibility, of course, would be your fibers, your fiber network. So you can use optical fiber. Yeah. So we go again. We have pilot wires, which are your copper pairs. We have pilot channels, which are your copper pairs interspersed with repeaters. Then you have microwave, you have power line carriers, and of course, you have optical fibers. And the optical, for the most part, because of the infrastructure required for your optical fibers, these are normally rented from your communication provider. And as I mentioned last week or the week before, where Jamaica is concerned, that is no flow, right? Everybody else rents from them. They are the only one who have really gone ahead and invested in that going around island. Yes, Mr. Johnson.
Yeah, does JPS use a power carrier?
I believe that has been phased out for the most part. They are now reliant on fiber, primarily fiber. If you go on, you will the infrastructure is still there, and you will see it. You will see some of the infrastructure for your power line carriers. And at the end of this presentation, I'll show you what that looks like. So you'll realize that it is still there, but they use primarily fiber right now. And I'm not aware of them still using the power line carriers. All right. So in summary, in trying to just bring or draw a line under these, what we are saying is that the application of the communication method would be dependent on the availability. So in our case, at least when I was back in the communication sector, we did provide some facilities for JPSCO. However, JPSCO also at that time, interestingly, a lot of the people who left the communication industry and went to JPSCO actually went there to provide support to their communications department. So the utility had its own communication department, which would maintain their microwave system and their PLC system, right? Today, that department no longer exists. All right? And what they are using are the facilities from the communication providers. The second limiting factor would be the distance between the relaying points. As we mentioned, for your pilot wires, which would form part of your voltage balance system, that would limit us to the feeders, right? The length of the feeder that you would use such a system on. And then next, the terrain. And I spent a little time talking about that, whether or not we have mountains and we are able to now get the line of sight. If I can't get line of sight, then microwave is not an option, simply put. If you can't have the antennas properly lined up so that they are looking at each other, then microwave is not on the cards. Right? Where we are now in terms of, that's part of the reason you'll find at the main stations for the communication provider, they have these towers, and the towers is to facilitate the line of sight. Okay, so they'll have facilities that again, I go back to Manchester. That's what I'm familiar with that. You know, you have places like Shudley, Christiana, which are, you know, fairly high, and they are looking directly at Mandeville. So the operations takes place in Mandeville, but then it is transmitted to whether Huntley or Christiana, and then transmitted to Kingston or wherever we seek to pass the toll information. When I say toll, it's just long distance communication. Okay. And then, of course, cost. Now, in the case of the utility, I mean, I can't speak to all the details regarding what it was costing them to operate their communications department. But, you know, that closure, that change in operation was quite sudden. Yeah. So one has to think about how much were they paying, you know, all these people to maintain the equipment. And they were basically replicating a communications company. So, you know, you go to a substation and you pick up the phone and you call the other substation, it wouldn't be costing you anything. But at the same time, what's the point in, you know, maintaining all these multiplexers and demultiplexers and antenna and all of that? Yes, simply for your protection system. Once you had the facility that you could now rent from the communication company, then, you know, it becomes a no-brainer. And the same thing, well, this I'm sure you are familiar with, yes, because they only started changing out the meters to the smart meters recently, yeah? It's a couple of years. So if you know the evolution within the last five to 10 years, the utility company moved from the electromechanical meters to digital meters. And so soon as they put in the digital meters, they then went to the smart meter, all right? And that transition is because they were now able to piggyback on the communication network in providing meter reading services. So there's nobody that they, or no department or a large cadre of persons they now have to rely on as meter readers. So persons were quite comfortable in a job as meter reader. Now, you know, they are a scarce commodity, yeah? So cost, maintaining these persons, paying for them, are considerations that the utility would have looked at, all right, in deciding the type of communication system that they would use. All right, so in terms of application, I'm now going to try and tie it to the schemes that we looked at last time. We think of unit protection. And as I said, although this is unit protection, differential protection, whether it is by phase or current, signaling is used to convey information concerning the relaying quantity. All right. So if we were using the unit scheme for the feeder, we have to be able to send the information from one end of the relaying or one relaying point to the next. So from one substation to the next to facilitate or provide the relaying quantity so that the decision can be made by the relay. In terms of comparing the local and remote signals, we are then able to have the basis on which we not only detect the fault, but also discriminate. All right? So whatever we are looking at, whether it is distance, whether it is unit protection, what we are saying is that between relaying points, and relaying points here simply means between substations. All right, we have to have that communication network. So that's for your unit schemes. In terms of what we were looking at last time, I put them together and refer to that now as your teleprotection commands. Right? So your distance schemes, and next time we meet, we'll talk about directional comparison schemes. They use signaling to convey a command. And that command is usually initiated in the form of you closing a contact. Yeah? And in closing that contact, going back to what we discussed last week, think of all the systems. You're closing that contact, you're sending a signal from the remote to the local. So it's going from the remote, it's received at the local, a decision is made at the local. Then of course, if the reverse is true, then our local now becomes the remote to the other local point. And using that, then the decision is made. We also note that in terms of the continuing with teleprotection, the additional information that we get is used to support or speed up clearance of faults within a zone, or prevent tripping for faults outside a protected zone. In a sense, what we are talking about here is that sending the signal, we are providing that inter-tripping, permissive tripping, all of that we looked at, as against blocking. Yeah. So it can prevent tripping for faults outside the zone, and it also facilitates faster clearance. Okay. So all of what we are saying has to now be tied back with the schemes that we looked at last week. Just to delve a little more in terms of the inter-tripping, we have for your, can I move?
Just some seconds, sir. You can go ahead.
So for the inter-tripping, as we mentioned last time, once you send the signal, right? So the signal is used to trip, or to convey a trip command to the remote circuit breaker. And this is the one that we said didn't require any supervision. So once it receives a signal from the remote end, it knows that a zone 1 fault would have occurred. And so it will trip automatically once it receives the signal. So going back to the media that we spoke about earlier, you can now understand and appreciate the need to ensure that noise is not represented as a signal. Good, which is why you need that threshold. Because if you're then getting noise, the possibilities that you will trip the circuit unnecessarily if you are using an inter-tripping scheme. So with the inter-tripping scheme, noise is a death knell to the system. All right. When we spoke about the zone 1 extension, one of the things we required with your zone 1 extension, we said that it was when you had no signaling available, or you had to remove your signaling, you would put that in place. But then when we also now think of our acceleration scheme, you need the auto reclose function, right, as part of that operation. So again, the provision of appropriate communication and signaling systems. Right? Now we're going to make mention of, the words of security and reliability in terms of our signals. They become of critical importance to your system. So we can't afford to have noise causing trip. Neither can we afford to have noise suppressing the signal that is sent. So we go back to the simple concept in physics, the constructive and destructive interference. Yep. If you are intent on sending a signal, but that signal is suppressed by noise, right? And noise here, again, we keep it simple, just an unwanted signal. If that is suppressed by noise, then it means that you would not have received the intended trip signal. And so you would not have done what we are seeking to do, which is to speed up clearance of the fault at both ends in that end zone that we have been talking about. All right, I've been yakking now for 30 minutes. Any other questions? Or is it so nice and simple? I like when it's simple, Oh, by the way, while we're at it, Ms. Gray, did you check the ERACs after we spoke? Did you check it any at all today?
No, sir.
No. All right, I did send the thing to to people in the UK. They responded and said that they were able to get on, but they will check to see what is what. All right. So the teleprotection systems are often referred to by their mode of operation. And we went through this. I know I introduced them to you last week without getting into this. So we talk about your intertripping or your direct or transfer tripping. And this is where you're gonna trip simply because you received the signal. All right? So there's no monitoring. There's no monitoring. So the system, we will call it intertripping or direct transfer trip, because the command, which is unmonitored, allows or causes circuit breaker operation. So the mode of operation is unsupervised receipt of a trip signal via your medium. So if you intend on using a direct transfer scheme, then you have to give careful consideration to the type of medium that you're going to use to convey that information. If it is susceptible to noise, then you recognize that the intertrip scheme would not necessarily be the one that you would want to institute. Now, I'm saying all of this to you because one has to give a full picture. Fair enough? But giving this full picture, I'm quite aware that many utilities would not use this, all right, because of the sort of challenges that it poses. Okay. So we have the intertripping, but we also have your permissive tripping, which now requires supervision. So the commands are monitored by a protective relay. So once you receive, you must have an AND function. So you must have, remember we gave two permissive schemes. We gave the permissive underreach and the permissive overreach. And it was just which one of the instantaneous zone settings that was used to send the signal. One was the instantaneous zone 2, and the other was the instantaneous zone 1. But they were both monitored by the zone 2. So you had to have a zone 2 signal on the receiving relay, as well as receiving the signal from the zone 1 or zone 2 instantaneous contact from the remote. So that's what governs the permissive stripping. Right? And this, you must, it means that a fault exists if that occurs. If receipt of the signal is not supported by the presence of zone 2, you're on your own. All right? And then finally, for your blocking. So we have intertrip, we have permissive, and we have blocking. For the blocking, we are receiving a signal if we are to block. Otherwise, there's nothing. So when we looked at the blocking scheme last time, what we saw was that the practical blocking scheme had a channel in-service monitor. So you have to ensure that the system required to send the signal is working at all times, because we are operating on the principle that I'm receiving a signal only in the circumstance that I have to block. Otherwise, we will operate. Any question, comment, concern? You guys scaring me now, but anyway, let's continue. Scaring me real bad. But after 2 modules, I'm sure you have learned, right? And you know the animal you're dealing with, right? So let's move on. All right, so what I'm going to do now is just to look at a diagram, just showing what is happening at either end, at each substation, all right, and the communication in between. So we have here, this is station 1, yep, station 2. Good. So we can either be using an intertrip scheme. I think this is in your lecture notes, all right? So we can either be using an intertrip scheme, meaning once it is sent across the communication link, once it's received at the other end, then we operate. Or we can have permissive, yes, once it is received, but also supervised at the other end. So what we have inside here is showing supervision. So you have to have that AND function. So both these normally closed, normally open contacts would have to close. With me? So it must be sent across the medium, but it must also have the zone 2 monitoring on the other side. So that's the AND function that we have there. And then we can also have blocking, yeah? And note on this side, we have the normally closed. So the reverse is true. I see you're twisting your head, Mr. Johnson, but I'm assuming you have read or you have gone through the video from last week.
Not yet, sir. I'm going to tomorrow.
Okay, all right. Okay, so then of course, as I mentioned before, you have telemetering, you have control, you have the telephone service and other data services. Because you have the communication link, you can do all of that between substations. All right, so I can, from one station, pull information from another station via the communication system, because they are all interlinked. They are linked together. Okay, so we're saying that as a matter of fact, if you, oh boy, I'm being very delinquent now, but I'm trying to get a video because we won't be able to physically go into, but then again, there's only 4 of us. I'm gonna try and see if that can work. Go into the substation or to get a video from them done. But once you go in there, regardless of the substation you go in Jamaica, what you're gonna find, you're gonna see a rack with all sorts of wires on it, but the wires go nowhere, because that is what obtained prior to them using the renting the facility from the current communication provider. All right, and that allows for all of this to take place. You pull information from relays. Most of our digital relays now provide a lot of information. I see a hand, Mr. Dance, just a minute. So when you go in and you pull information, let's say from the distance relay, what used to happen in the past is that, let us say I have a fault on the Hope to Cane River line. All right? Now, Cane River don't have Woy. Yeah? What you would have is the line opening. What the engineers would then have to do is to track the line. So you might say, well, yeah, they have a power cut due to an open line, a fault on the line, and breakers open. You can't reclose them because the fault is there, so you now have to physically go and clear the fault. You would have to walk along the transmission line to identify where the fault has occurred. Today, in the substation, you can interrogate that distance relay, and it tells you within a couple meters where on the line the fault exists. All right, and that is all a part of the whole communication system. Yes, Mr. Johnson.
I was saying that if I could talk to you after class regarding visiting the substation.
Pardon?
I was saying if I could talk to you after class regarding visiting the substation.
With somebody from protection?
Not protection, engineering services.
Well, I suppose that's Ricky's department.
Yes.
Well, I suppose he could ask somebody from. Well, yeah, okay, we can talk. What I will do, since it's a few of us, I was harping on doing the video because I wasn't sure what was happening with the COVID. Yeah. It's a small number of us, and the restrictions have been relaxed somewhat. So if needs be, I will just arrange for us to have a physical visit there before the semester is out. All right? So we'll work on that. Okay. All right, so this is what the communication system would look like. And as I was stressing, and sometimes it is not clear, that what we show on the in terms of the trip schemes, we are showing it at one substation. But I want to always remind you that whatever is at one is replicated at the other. All right? Okay. So how do we judge the performance of your communication system? And performance is expressed in terms of security, and the security is a function of the probability of an unwanted command occurring. Right? So performance is a function of the probability of an unwanted command occurring, while dependability is a function of the probability of missing a command. So I'll go again. For security, it's based on the probability of an unwanted command occurring. And dependability, the function of the probability of missing a command. Now, immediately this should tell you that where security is concerned, since we're talking about an unwanted command occurring, then that is going to impact more of our strip schemes, whether permissive or direct or inter-tripping. And then dependability is going to be of greater importance to your blocking schemes. Okay? But let's not get ahead of ourselves. So security and dependability are based on one, the mode of operation, the communication medium, and of course, the operating standards of the Power Authority. So what it is that the utility has set as its operating standards. All right? And we look at a figure next, which will hopefully give us a better feel for what we're talking about in terms of security and dependability and how they relate to the different schemes. All right, so for our schemes, what you have here are the three options for trip schemes. You have the inter-tripping scheme, you have the permissive trip, and you have the blocking. So for the inter-trip, as we said before, these rely on the receipt of a signal to initiate tripping. Yes? For the permissive, we are monitoring the signal that is received. And then for blocking, yep, the signal received prevents tripping. So what these graphs are showing you, and I don't know if you can see clearly, but if you look down here, security, remember I said it was just a function of an unwanted signal occurring, right? And dependability was a function of missing a command. So for security, it is 1 minus that the probability of an unwanted command occurring. So the smaller the probability of getting an unwanted command, it's the higher the security of the system. So the smaller the probability of an unwanted command, it's the higher the security. The smaller the probability of missing a command would be the higher the dependability. All right? So with that said, we also want to take note of the operating time, the maximum operating time. which are shown here. All right. And this now corresponds to what we said last time, that in terms of your blocking scheme, because nothing occurs instantaneously, right? And that is the higher level of reasoning that we had last week, Mr. Johnson. But the others, I'm sure, remember that level of reasoning. Right? So, because nothing appears instantaneously, the blocking scheme would be the fastest. All right. So in terms of operation, right, your blocking scheme would operate fastest. Now, we start with the intertrip. What this is saying is that with PUC low, that is receiving an unwanted command, with that being low, what it means is that the security here would be high. What do you think?
Yes, sir.
When you come here, receiving an unwanted command, in terms of security, it's not that it is low, but it is lower than that for intertripping. So it is more tolerable. That's what we are saying. In receiving an unwanted command is more tolerable with your permissive trip scheme. And this is true because you have that AND function. So if you receive the unwanted command, you are not immediately moving into tripping because the signal has to be monitored by another signal. So you would have to have both errors occurring. And these errors would be occurring at the remote and at the local. What do you think? So in terms of security, it is, yes, still important, but not as important. If you look on the blocking scheme, security can be a little higher, can be a little lower, meaning the probability can be a bit higher. However, let's look at the reverse now for dependability. Because dependability now speaks about missing a command. Yes, Mr. Buchanan.
Sir, I'm a little confused. So these are not stating what's the likelihood of like an unwanted command occurring. It's stating like how much they can tolerate an unwanted command occurring.
All right. What is showing us is that for your intertrip operates with a communication system with a much higher security than that of the blocking. So you require higher security for an intertrip scheme if or when compared to a blocking scheme.
Oh, okay, I understand, sir.
All right. And then the reverse is true. If you are now looking on dependability, because remember, dependability is missing a command. Probability of missing a command. Now, if I miss a command, let's look at the blocking scheme. If I miss a command that was sent for the blocking scheme, it means that the blocking scheme would not operate. Let me throw back something in the mix to make sure that everybody understands what is happening. Remember that the objective of all these trip schemes and all this communication, what was the objective? I was saying, remember, but I'm coming back at you. Huh?
Oh, to get the relay at the other end to operate faster.
Exactly. So it isn't that the relay at the far end will not operate. The only problem is it will operate in zone 2 time. Yeah. So the intertripping scheme and the permissive scheme and the blocking scheme is simply to speed it up. So you want it to operate as close as possible to the zone one time. So you can remove both ends of the line. So with that in the back of our heads, what we're saying is that the intertrip requires higher security. Yeah, because if you have the system being influenced by an unwanted signal, meaning if the probability of an unwanted signal is high, yeah, meaning low security, then it's going to cause the intertripping scheme to operate when it should not. Yes? With the blocking scheme, if you send a signal that is unwanted, it will not impact anything because it will not cause the blocking scheme to operate. Because the receipt of a signal by the blocking scheme is to prevent it from operating. Are you with me? When you flip the script and look now at dependability, which is missing a command, if you miss the command with your intertrip, it is of concern, but it will not destroy us, so to speak. Yeah. If you do that with the blocking scheme, right? So if you have low dependability, meaning the probability of missing a command is high, based on the communication medium, yeah? If that happens and it misses the command, it's going to operate and therefore take out a line that it should not have taken out. So you're gonna then impact more customers than you need to. I hope I have not muddied the water anymore. Okay? Any other question? This is the time. You know. I realize Miss Gray and Mr. Duncan can't take us anymore. They gone.
Sir, I'm here. I'm here.
I'm here, sir. I'm listening.
Yeah.
Just need some absorbing.
I know it's a lot, but the video is gonna be there. So this is what I just said. One, the operational modes affect security and dependability as outlined. Firstly, for your intertripping, given that any unwanted command causes incorrect tripping, very high security is required at all noise levels up to the maximum that can be encountered. So in other words, your communication system must be able to mitigate any potential noise that would cause a false signal to be created. So it must have high security. Yeah. So if you are using an intertripping scheme, then you look at the communication system that you're using, and it must be one that has very high security. The probability of having an unwanted command must be very, very small. All right. Next. Yeah, Mr. Jones.
I don't know if I'm jumping the gun or misinterpreting, but would we, for example, say that use fiber optic instead of using something else? Is that the communication channel that we're referring to?
What do you mean the communication channel?
You
I have
said
not-
that
I've not zeroed in on any, you know.
I'm asking if that is what we're referring to. Can you use that word when you're describing them?
No. I said the communication medium. So it's
Yeah, the
not
medium.
necessarily the pilot channel or pilot wire I'm referring to. Remember, I gave you all the options.
Yes, sir.
I'm assuming, it's something that I do not want to admit to, but it's just our reality. Unfortunately, in the next 10 years, one of you going to write me from somewhere across the globe. Right? We're just not retaining our people. So if you go in a jurisdiction where these options are available, what I am saying to you is that these are now the considerations you have to make. So if you are using an inter-tripping scheme, one in which there is going to be tripping simply by receiving a signal, then when you look at the communication medium that you use to facilitate the inter-tripping, it must be one that is highly secure. That's the point we're making. Right? If you're using, well, let me give you the others. For permissive, right, it is less critical with the inter-tripping because you have the supervisory component. So you have that and function. So whilst security is important, it is not as critical. So it means that you have a little room to play with. Yeah? When we're now dealing with the permissive overreach and the whole resetting function, yeah, we are saying that you need dependability. Because, as part of the resetting function, you don't want to miss a command. So dependability and security for the permissive scheme are not equal, but are of almost equal importance. And then finally, for your blocking scheme, right, for your blocking scheme, low security, you can deal with it. It's not that you are going out here to say, well, yeah, I need a low security system. What we are saying is that if there is low security, it is more tolerable for a blocking scheme. So if the communication that is available in an area is not very secure, meaning the disturbances, the noise that you have present in the area can give you a false signal, but it is highly dependable. Yeah. And a dependable medium here could very well be a copper pair. So it's dependable, but not very secure because of its exposure. It can pick up noise. We're saying then maybe a blocking scheme is what you want to use. All right. So to try and summarize, so we have given you the impact of security and dependability, depending on the system we're using. But more generally, we're saying your transmission media, the signals are subject to noise and interference associated with each communication medium. So depending on the medium you are using, the susceptibility to noise would vary. So if I'm using the copper pair, if I'm using all right, think about it. Remember what I said about the microwave systems? What was the main criterion for using them?
Antennas have to be in line of sight.
Antennas in line of sight.
Line of sight. Okay? Now, the question is, if I'm using, because I have to do that, would I want to put or use microwave in an area that is subject to high winds?
No, because that might lead to signal attenuation.
Yeah, it might shift the antenna. Can shift it quite easily. And immediately you lose the line of sight. You get what I'm saying, no? So you could miss a command, and therefore it is no longer dependable, because the probability of missing the command has now increased because you have put it in an area which can impact your antenna. And so that noise can impact the signal that you're sending, or it can falsely present a signal. So the one that you're sending can be impacted, or it can show itself to be a signal when it isn't. All right. There are some other points I just want to make quickly. Nothing that you really have to write, but I make the point nonetheless. As it relates to continuing on transmission media and noise, we have telecom equipment, all right, operating over a power line carrier. And, we can incorporate other information on it. Multiplexing is just adding signals. You have different frequencies, you add them and then you strip them at the receiving end. Okay? And so you then have that one signal. You put information, you put it on top of a carrier signal, and you transmit it. Okay? You transmit it, and then at the other end, you take it off. So the things I mentioned earlier, where you can have telemetering. So this is how they can now stay at system control and actually be measuring the amount of power being supplied from a substation. That's the metering, and they can pick up that information remotely. Right? That's a little different from what now obtains with the smart meters. Right? That one uses the same cell phone technology that we are now familiar with. All right? So that is in play. But we can now measure the power, measure what is happening at the substation. And in that way, the utility recently talked about its, what they call it, transformer protection program, where they were removing certain communities from the system. All they were doing was just monitoring what was happening in the communities, and they know the number of customers they are having, and all of a sudden they see that their consumption in that area gone through the roof. It's transformer protection. You're protecting the transformer. So you shut down the area. Right? But of course, we need to get away from this good suffer for the bad argument. Right? And just do the thing properly. But yeah. So in terms of just, you know, putting all of this together for an appreciation. So you have the protection equipment. And you can then, as I said, strip from it what you want, whether the metering information, whether the voice. So you can have a telephone network, you can talk between substations, you can, yeah. But if all of that is not available, yeah, or simply unsuitable, you can then set up your own thing. And that is what we are going to look at in terms of the power line carriers and all of the options that are available. And don't worry, I'm not going to ask you to draw this in an exam. By the way, when is your mid semester? It's this month, eh?
Yes, sir.
Sorry, 22nd.
It's so far, it's what happened to me. But that's almost at the end of the module. And it's up to what, week 8 or week 7?
Week 7.
Week 7, so that's up to last week then. That is, or is this week 7? Week 7 ends today, right? Yeah. All right, good. So it's up to today.
Sir, didn't this say up to the week of February 10 or something like that?
Is that what I said? All right, cool. Just trying to remember. Whatever it is, I would be consistent. I just go back and check. All right. So just to summarize everything, here is our system. So we have our protection relay scheme. That's here. Yeah. On that same medium that we are using, we can have voice, you have the carrier frequency, right? Note up here you have your pilot wires. So that's where you use twisted pairs. Here you have your pilot channel where you have the wires up to a point and then you repeat it. Okay. I can also have this superimposed on the power line itself. Okay. And what you are seeing here, right, would be a wave traps. Okay. Or you can do the multiplexing, which is basically creating your own communication system, and you transmit it via the antenna. So this would be microwave here. All right. And the pulse code modulation, what can be done either via the radio or optical, which is why the transition JPS for me, it was not so difficult, because the main area or the main method they were using up to a few years ago was microwave. And the microwave antennas, you can still see them on top of the substation house or the relay houses. Yeah. So using that, you can then use the optical. I use your fiber, or you can have dedicated fiber for your protection system. Okay. What they now do, as I said, is to rent. But just to zero in on what happens with the power line carrier. All right. For your power line carrier. Oh, and the other thing I need to point out, I believe this is in the lecture notes. I honestly didn't check before I came here today, but it should be there. So this would be your protection signaling equipment. So that's the relays from, based on what we would have looked at. So your distance relay, whatever. So that's the equipment here. All right. And then here is the medium. Right? Communication equipment, and then, the equipment, and then the media that you are transmitting with. And then you simply take this and reverse it at the other substation. So you pick up the media, comes into the communication, and then goes back to the protection. All right? And of course, you would appreciate that all of this is very time sensitive. The times that we're talking about, remember we're talking about a couple 100 milliseconds. Yeah. So it means that, we're talking about very short communication. We have to look at the speed at which the signals can be transmitted over the communication media. I know I didn't really specify that earlier. And then when we focus or drill down a little further with the power line carriers, all right, I'm sure you would have seen this already. And for your power line carriers, we don't know, just taking you into the substation. Right? So at one end, we have the line. So note that the entire communication and information section of the protection scheme does not impact customers. Right? Doesn't impact customers. So what you're doing, so to the line, you put that on, coming into the station, you take it off. So we have the line traps that are on the power line that prevents that information from coming into the system, into the station. Are you with me? So it's out there. It is not coming to the customer. So the customer would not experience all these additional frequencies. What they would get is the power frequency, which is the 50 hertz. But all of that is trapped. That's what the wave trap is for. And it's basically, call it a resonant filter. So it takes that information off. You're able then to bring that down, do the processing. All of that information is processed. You do whatever you want to do with it. Use it to make your decisions, right? But here and here, you take it off, you put it on to go on the line, but you take it off at the other end before it gets into the station. And so what you would see when you go to the substation would be something looking like that. So this big cylindrical thing that you always see on the line, that's your line trap or your wave trap. All right. So it takes off the signal, passes it down for processing, but it's not allowed to come into the station and impact. So it wouldn't come onto the transformer and then to the customers. But it's taken off and sent to the relay house. Yeah, I kind of snapped this. Yeah, it wasn't at a very good angle, so it looked not very circular. All right, but it's a cylinder. Just take it from me, it's a cylinder. Okay? Yeah. This was done by Rockford. All right. Yeah, that's all I have to say to you this evening. Yeah, we can make some arrangements. I gather Miss Gray coming to Kingston soon. Mr. Buchanan, you're in Kingston also?
Basically, sir.
Which parish that was, man?
St. Catherine in Portmore, so
Okay.
same area.
How about you, Mr. Duncan?
I can make it up, please.
All right. So we make the arrangement. Antonio, you have my number. We can talk about that. All right.
All right, sir.
I need to send an email. I've just been I'm sorry, I know I'm not as focused as I would normally be, but I have my feet in a few things at the university. So you go. All right. I'm sure you'd prefer to do this than do it by independent study. You tell me. All right. My only requirement is that you ensure that we are over the 3.0 with the GPA at the end of it. Okay, that's all I'm asking of you.
Okay, sir. So you could just start the recording when you finish. No one else has a question, so I can ask another question.
Go again.
Just want to ask a question.